Hi, everyone. Thanks for coming to my talk, Hyperscalers and FinCrime, a match made in the cloud. I'm going to go a lot louder. Thank you. Keep doing that, by the way, because I'm going to need that. All right, so that's me. I currently work as the Senior Director of Security Detection and Research at Datadog. We do cloud security stuff. And much like Brazilian Jiu-Jitsu and much like CrossFit, if you run a newsletter, you have to tell everybody that you run a newsletter. So that's my newsletter. A lot of the content that's in there, a lot of people in this very audience wrote, so thank you so much. I really appreciate it. But yeah, I have a lot to talk about. I split the talk into 3 buckets. Basically, I'm going to do some buzzword bingo on cloud service providers. You saw the word hyperscalers, so a bunch of Wall Street analysts got really excited probably if they heard that. We're going to talk about how Datadog models cloud threats for detection opportunities, and we're going to do some case studies here, specifically into 2 buckets. One bucket is going to be using the cloud to go and do something else outside the cloud, and then cloud as the actual primary target. And so when you hear the word hyperscalers, you mostly think of these 3 different companies, right? Amazon, Microsoft, and Google. And there's many reasons why it's called hyperscalers. You go and look on their websites, you pull things up, you start to notice that it's not just somebody else's computer. They offer hundreds of services that a developer can use to go and write code, deploy, start a company, right? Go and look at it for Azure. Notice it's over 200. I don't know if they're competing and making sure they have that in their marketing copy. And in the most Google way possible, they don't say how much they have. They have an interactive map of all the things that you can go and do. I counted 237. So all of them are really focused in making sure that they can create all these different types of services so that developers can write fast. And it's very similar to how a programming language would work. So maybe you write Python at one company, you go to another company, you're going to use the same tool set, right? So it's very similar. You go to one company, you're working on Amazon, you're working on GCP, you go to another, you're going to do the same thing. And so the threat model that they generally follow revolves around something called the shared responsibility model. Google calls it the shared fate model. Again, Google, they have to do something different. But the basic premise behind it is that you're responsible for certain things and securing them, and we're responsible for certain things and securing them. And there's a little bit in the middle that we're both responsible for. And so what this does is it creates these homogeneous environments. They're built for scale and rapid deployment of new services. The problem with these homogeneous environments and when you're adding new services is it creates an information asymmetry. What that basically means is that as these cloud service providers are making more things and you're trying to make more things with them, cyber criminals are also taking advantage of this. And they're not really banking on the fact that you know everything about all the different services that are being deployed. And so they're built to rapidly launch these. It's all about the line going up, right? And so this is taking advantage of that. And so the question becomes, how do you precisely describe a cloud service attack? And again, more than just crypto mining, right? And so what we do at Datadog is we try to answer the where, what, why, and how. And so the where is basically where is the attack in the cloud being performed. And so obvious one, cloud. This is like I log into Amazon, I log into my Azure tenant, and I can configure things, I can launch things, right? But as you move kind of closer and closer to where the code's being run, you start looking at the cluster, the actual EC2 instance, the compute node, the virtual machine, and a lot of the orchestrators like Kubernetes and things like that. Things run on these orchestrators, things run on these EC2 instances. Containers. This is like the de facto standard to building like a hyperscale company is you're deploying containers and that container contains code. And so when we're thinking about where is this attack occurring, we first say where did it first start, and it can start in any one of the 4 Cs. And by the way, from those 4 Cs, there are attack paths to go and navigate between everything here. So it can go from code to container, cluster to cloud, cloud back to code. And so it's kind of important to kind of realize like it's a little bit complicated to really go and perform all these different types of detections, right? The next is specifically the data on the wire. This is the what can we see. Typically, the cloud service providers talk about 2 things, the control plane, the data plane. The control plane is I'm booting up a database, and this database is going to be a certain version. I'm listing my databases, I'm removing them. The data plane is the data inside the database, so specifically what I'm putting in there. A lot of these, like Amazon, for example, calls this the value. Data plane contains the value of a company or of a cloud, right? And so looking at how can I find different detection opportunities between these 2 is a really important thing when you're trying to track all of these different intrusions. The next is the who. We call this the bot or not question. You go and you look at identity and access management on almost all of the cloud service providers. They always talk about whether an identity that's interacting with these resources, is it a human or is it a machine? And there are different things that you can baseline based on that behavior. A dev does certain things, a database does certain things. So baselining where this is, who's doing it, and whether or not it's a bot is very important. And then lastly, the how. This is kind of where MITRE comes in. And MITRE ATT&CK, we leverage MITRE ATT&CK pretty heavily, at least for the cloud. It does have some things that like kind of repeat between each of the different stages, but it's because it's kind of showcasing all of these different components of the where and the what. And so it's very useful for us as we're modeling these. So quick recap, how we put this all together: where, what, who, and how. So where in the 4 Cs can we find telemetry? What information is available in those data planes or control planes? Who is the identity type interested in the cloud resource? And how can a T code describe the tactic? I stole this from the Proofpoint folks. I think they said it on one of their podcasts, the T code for MITRE ATT&CK, like very precise and concise, which I love. So I talked a lot about what it is a hyperscaler, why there's an information asymmetry, why it's really targeted for devs, and now I'm going to start showing everyone a couple of things that we've seen at Datadog, as well as things we've seen in the wild, and kind of model it using that threat model that I talked about earlier. So we recently wrote a blog post where a threat actor performed a resource hijacking attack to do a phishing campaign, specifically smishing. I think I'm allowed to say that, or SMS-based phishing. But the basic setup of it, and the way I'm going to do this, is a sequence diagram. So you have the participants at the top, and then I'm going to walk through each one of the 4 Cs, data plane, identity, things like that. So we had an IP address that we were tracking that was interacting with a ton of tenants. And what it basically did is it loaded a bunch of stolen AWS keys on this specific piece of infrastructure. And it took those AWS keys and started talking to these victim cloud service provider environments. Specifically, it was saying I was performing some control plane API calls, and those are get caller identity and then get SMS attributes, and I think get SMS sandbox status. And what that basically was checking was, given this AWS key, can I start sending text messages through the Amazon Simple Notification service? And if it can, it went back to that attacker so they can carry out the next part of their attack. So there's a detection opportunity right there. The next part of the attack included using a lot of those access keys to go and issue a data plane event, which is send the text messages. So a lot of these customers and a lot of these honeypots that we had set up did not have text messaging through SNS enabled. And so we saw a spike of data plane events, specifically to go and target phishing victims on the right. What was interesting about this one is that the same infrastructure that was interacting with these victim AWS environments was the same infrastructure that was hosting the phishing website. So this is kind of like a larger, interesting detection opportunity where if you see a spike of this traffic, and it's coming from an IP address and it's issuing a ton of data plane events, you can actually pivot on that IP address and find an associated phishing website. So we thought that was kind of cool. But this is Sleuthcon. How the heck did this happen in the first place? So let's go sleuthing a little bit. So really the economy behind this initial access for these stolen keys kind of boils down to this. An attacker will go and scan the internet. They'll look for code repos, environment files. They'll look for blob storage devices. And they're basically grepping out different types of access keys. And from those access keys, then they can leverage that to go and attack these environments. And then the question becomes like, is this working? You can go on Grey Noise right now, go and look at their env crawler tag, and you'll notice that even just over the last month, you'll see a bunch of internet activity just scanning for these environment files. If you notice at the bottom too, they're also leveraging a couple of vulnerabilities. And so maybe it's not misconfigured to expose an environment file, but it is misconfigured in the sense that it has a vulnerability. And so they can jump on there and pull those access keys from those files. Let's go sleuthing even more. Go on Telegram. If anyone has a Telegram account, if you'd like, type in a bunch of cloud service provider services, in this specific case, SES and SNS. You'll see all kinds of advertisements for this type of access. Some things that are interesting, SNS is for SMS, SES is for email. So instead of hijacking an email account, they're just going to hijack a cloud service provider and a victim there, and they're going to use that to send out emails. You also notice that there's 50,000, 100,000, and 500,000 quota. That's that sandbox account status that you saw earlier. Basically breaking out of that sandbox and saying, I'm no longer a dev, I'm going to spend money on you, Amazon, and I'm going to send this a bunch of email, I'm going to send a bunch of text messages, and they now have really reliable, trusted infrastructure for these campaigns. So that's one of them. And a lot of these dev misconfigurations, they lead to these long-lived access keys, but that's targeting the machine, that machine identity I was talking about earlier. How about targeting devs directly? Is there any payoff if you can target them directly to get access keys? Because that's what devs use. They use that to interact with the cloud. And so, this is a tweet from a few years ago, super interesting campaign where basically a popular Python library and a popular PHP library were compromised, 3 million users combined, and the malicious code was basically enumerating environment variables and sending it to a Heroku app. Nothing here specifically, well, they said AWS, but if you go and you look at some of the malware, so for example, this was the malware in that backdoor PyPI package. Enumerate the environment and send it off to this Heroku app. Nothing here that kind of indicates this is targeting the cloud. But if you go and you look at the PHP version right there in the middle on line, I think 47, 48, it's specifically targeting those access keys and specifically targeting those secret keys going to that same Heroku app. So pull up the sequence diagram. The basic premise behind this is that someone's compromising a developer account that holds these popular packages, and then you're shimming in your legitimate or your malware code. You're then uploading that to a registry like PyPI, and then you're waiting for someone to either run it on their laptop or run it in prod or staging or a build environment, and then that's when it gets downloaded. Whether it's on any of those environments, it's now enumerating secrets, it's taking those and it's bringing those back to that attacker-controlled infrastructure. But again, this is Sleuthcon. How did this initial access happen in the first place? So let's go sleuthing. So this is a screenshot of an actor named John Malkovich who eventually became Evil Proxy. And this post was 4 years ago, but basically they're advertising their phishing kit. I've done phishing research for years, and this was the first time, if you see the red box at the bottom there, I've ever seen templates for registries. So this is, the victimology of this is really somebody who's a developer. That was years ago. Recently, if you kind of search for these things, you'll notice other actors talking about access they have to different rats and different botnets. And this particular one was saying that, hey, we get to these different installs through compromised apps, or sorry, compromised packages. So on PyPI and Golang and things like that. They made a post afterwards, kind of describing a little bit more. You can read it top to bottom. Basically, anything that you can see on the registries, how many installs it has per day, where it's hosted and things like that. And so they're constantly thinking about how can I get access to these popular packages so I can shim in malware and then get installs on it. If you read the end, they're talking a little bit about they're interested in a victim set targeting like crypto wallets. And I would say there's probably a Venn diagram between developers and crypto holders. But it's still kind of interesting to note that are they targeting the cloud? Maybe. But at the same time, like this is the evolution that I've personally seen where you target folks that hold crypto and then you realize the payout's higher if you target companies themselves. So I thought that was a pretty interesting finding here. So I talked a lot about like cloud is like an ancillary target, but we're starting to see a lot more, and I know a lot of folks here are seeing this too because I've had a lot of great conversations already, where cloud is the primary target. It's the thing that they want to get access to because they want to do something to the firm that runs that. And so I can't really talk about this without talking about Scattered Spider or Muddled Libra, but this is an amazing blog post by Margaret Zimmerman over at Unit 42 that basically talked about Scattered Spider's evolution to the cloud and all the associated TTPs with it. So they're showing that they're learning how to navigate within these environments, and they're doing cross-cloud too, which is also interesting. I'm not going to model everything that happens during an intrusion because I want to hone in on something specific, but the basic premise behind it, and I'm sure a lot of people here know, when you get into a cloud environment, it's somebody that has privileged access to it. Who is that usually? Either an IT person or a developer, right? So they'll socially engineer them, they'll achieve some type of session cookie steal, or they'll add some secondary MFA. They pivot into the cloud service provider. They set up persistence. It's not just adding things like a user, but they're doing things like setting up rogue identity providers and tenants, and they're using that to pivot back in. And then they're literally just enumerating as much as they can. And they're looking for a few things. They're looking for secrets, and they're looking for intellectual property, and then they exfiltrate that. And so, again, I'm interested in this part. How are these actors talking about this? Why are they interested in this specific thing? And so I have a screenshot from a supposed Alfie black hat actor here. I had to gray out a lot to make it safe for work. This was an interesting thread on Exploit where they were basically arguing with Lockbit. This was right before the Black Hat takedown and the Lockbit takedown. But the interesting part is right there in the red box where they basically say exfil is the only thing that actually matters. So it's kind of moving away from double extortion where they're ransoming a company and they're kind of really focusing on taking something from that company. Another interesting note too, you'll see the big screenshot right there. The way they prove they're in Black Hat is they said they were the one that submitted the Meridian Link SEC complaints. And so that's their proof right there. Really fascinating thread if you kind of want to see people bickering. It's almost like trash TV. You can't stop watching it. You like watching these like Jersey housewives argue. But this is where you can glean a lot of that intel, right? I think I was having that conversation with John earlier. Once they start infighting, like all kinds of stuff starts to come out. I can't really talk about cloud exfiltration without talking about Sisense. So for those that are unfamiliar, a few months ago, CISA released an advisory that basically said this business intelligence company, Sisense, was breached. And if you're a customer, you should start really thinking about talking to them and re-rolling a lot of your integrations with them. Our good friend Brian Krebs had an expose on this whole thing. He had insiders that had access to the breach data. So I want to build that sequence diagram just based on what's on this public information that Krebs posted, because it still kind of shows like people are really interested in targeting the cloud. So according to the article, there is a hosted GitLab server that was either misconfigured or vulnerable to something. Once that was discovered, the actor performed some exploit, or they took advantage of the misconfiguration to download source code. Again, devs. They're targeting the devs and what the devs do. Within that source code, they found AWS keys within that source code, and they used that to list the S3 buckets that Sisense owns, and they found a backup, and they downloaded it. And the whole implication throughout this post from Brian Krebs is that they were going to use that to pivot into customer environments. And so I thought this was interesting too, in the sense of they're not necessarily downloading Sisense code, or at least that's not what the blog post said, but they definitely targeted another part of intellectual property that is their customers. And if you go and you look at some of the emails that Sisense's CISO sent out, again, Krebs got a hold of this and posted it on the blog, but I put red boxes around like the cloudy things. But if you kind of read everything here, you can almost always associate it with the cloud, right? API secrets, Active Directory integrations, and things like that. So they wanted the secrets, and they want to use it almost in like a 3CX style supply chain attack to go and pivot into other environments. So again, exfiltration is really going to be a hotter topic. It's something I'm telling my detection teams to really focus on, because this is such a massive event that you can catch. But a lot of times when it comes to those detection opportunities in the cloud, it's kind of hard to put it all together and then start detecting it and then stopping it. I can't talk about cloud threat actors without talking about these guys, Team TNT. So Team TNT was a group that kind of emerged on the scene in 2019. This is their Malpedia page. What made them interesting is they're targeting cloud native technologies, that cluster and container component I talked about within the 4 Cs, specifically looking at Kubernetes, deploying malicious containers that they uploaded to Docker Hub, Docker itself. They did the boring stuff like deployed a crypto miner, but what kind of made them interesting is how they did their targeting and how they pivoted into cloud environments afterwards. And so the interesting part with this group too is that the main person tweeted all the time, all kinds of things that they were doing. So Hildegard, that's their Twitter, they still have it up. Notice that they're just like talking smack that they got into a customer environment or just a cloud environment in general. They also would go after like researcher firms, like this is Cato Security talking about like things they found related to Hildegard and Team TNT's tooling. And so this is just him, again, bragging and engaging with the community. So it was a really fun time, really interacting with Hildegard. The problem, if you look on the right there, is they retired. And so one of the first publicly reported cloud threat actor groups that showed expertise in these environments, Hildegard is likely the main actor of the group, but announced leaving the scene in late 2021. And one thing when they left the scene is that they took their tooling and they leaked it. And so since 2021, since that leak, at least at Datadog, we've seen all kinds of stuff, both in honeypots as well as some of our engagements, where we're finding code reuse. We're finding a lot of Hildegard and Team TNT's tooling. And so I wanted to highlight a specific campaign we saw from Team TNT, where we had an IP address at the top, the command and control server, hitting our honeypot, trying to get into our cloud and trying to pivot to other victim environments, both with those exposed Kubernetes and Docker APIs. Basically, the tooling would reach out, it would check to see if we had a vulnerably configured Docker API, and they would do a bunch of stuff, such as it would create a container, it would try to break out of that container, it would try to set up persistence via all kinds of methods, including cron jobs. It tried to steal the AWS keys that we had as a canary on that honeypot, and then would try to interact with those AWS keys. Afterwards, in like a wormy type of fashion, it would use that same machine that it tried to compromise to go and do more scanning of the internet, more ways to kind of add things to the cloud, and then it kind of end up in the crypto miner. But again, this is Sleuthcon. Let's take a look at this. Specifically, there are cron jobs that we notice that are uploading to a very specific endpoint at this IP address. Well, we as curious observers decided to access that upload API and it was misconfigured. I think they should probably watch this talk to learn a little bit more about securing the cloud. We downloaded a bunch of their tooling, we downloaded their bash history, we downloaded just basically everything they had on that C2 server. And then we noticed something in the bash history. We specifically found a unique password. So within the bash history, this is kind of a snippet of it. What this actor would do is they would access victim AWS keys. They would then load it into the AWS CLI hosted locally on that command and control server. It would do a bunch of persistence things like creating user login profiles, attaching user policies, basically everything in persistence you can think of. But the one interesting part was right there. The password, erdnubble1704. And I got really excited and my team kind of like was weirded out by me, but I'm like, we get to do the best pivot in threat intel, passwords. And they're like, okay, sounds good, Zach. So I took it and we put it in some breach databases and we got some hits. It's like, okay, maybe, we're not gonna get like full attribution, maybe this person's kind of small, but at least we're starting to see some hits here. And so we got an email address, which was great. That's another pivot that we're about to do in a second. We got an IP address. And we realized that IP address was in Germany, and Hildegard speaks German. And we're like, okay, it's a little weird, but let's kind of keep going here. And so we took that email address and we got a name. From that name, we found social media profiles. From the social media profiles, we found one specific person from around 2020 to 2021 talking about writing malware related to Team TNT as well as posting their screenshots. So, the question became like, who is this and is this Hildegard? And so I reached out to my good buddy Silas Cutler, who did a lot of work with Team TNT back in the day. He managed to find out who he was too. So I asked him, is Hildegard's name blank? And he's like, yeah, that's him, you found him. And I said, okay, we have some hands-on keyboard activity in a honeypot. It used a very specific password. He's like, oh yeah, he does a lot by hand. So Silas did all the hard work like years ago. And so specifically March 2021, he just wanted me to make sure everyone knew that's when he found him. So it really kind of came down to like, he announced he left the scene. Maybe he just got a little bit smart and still is doing what he was doing back then. He just wasn't bragging. And so, it is our assessment that Hildegard is kind of continuing operations. We have hands-on keyboard activity with a unique password tied to his name, further uncovered by other researchers who on separate occasions found his identity. And so like a good analyst, we did some analysis of competing hypothesis. Maybe other threat actors are using this password either through a collision or they knew it belonged to Hildegard. We didn't find anything of those passwords within any of his tooling, and it just kind of like seems a little bit far-fetched. It's not like a Hunter 2 password, and it's not like a LastPass, like give me something like 20 characters long password. It's something where we can go and pivot and find very specific findings in these breach databases. Well, the other competing hypothesis is, hey, maybe the tooling that he had leaked by Hildegard contains his password. I have access to all that tooling. Luckily, we were there when he dropped that tooling, and we found nothing related to this erdnumble password. And so I did what anyone does, reach out to Hildegard on Twitter and ask him if he's still around. He still hasn't DM'd me back. So that's basically the talk. I hope y'all leave here today kind of understanding a little bit more about the cloud. It's not just someone else's computer. It's about 237 according to Google. Other things that you can do there. It's kind of hard to track everything that's going on in terms of like where is something being attacked and what layers of the 4 Cs. But I hope you can kind of think about this a little bit more because threat actors are definitely thinking about this more. And it's something that I hope with this talk I brought to light. So thank you.